All right, so not only has Gabor great organizational skills, also great Photoshop skills, apparently, on video. So thanks for inviting me here. I'm really happy to be in touch with the Eduworks project, because Textkernel, better matching through bigger data, that's the slogan we didn't think of, but it's quite close to what we work on. And it's really great to be able to tell you a little bit about our work, because we have been actually working on vacancy mining and analysis since around 2003, and in a very commercial context, on a product called Joffe. So that's the main content of what I will be talking about today. And obviously, academic research has different set of objectives than selling products, but I think in terms of technologies and challenges and issues, I think we have a big common ground. And we're also happy to share our data for research purposes, which we're doing in the Eduworks project, and happy to hear your ideas and contributions towards the challenges that we are facing. So just as a first introduction to Textkernel, what we're doing, we call it semantic recruitment technology. And I usually try to illustrate why and what that is by this slide. Basically, in the labor market, people are interacting with employers in terms of language data, in terms of unstructured queries or CVs, social network profiles, and employers are posting jobs. That's the way the labor market traditionally works. And because this is unstructured language data, where the connection between supply and demand really happens is on the level of concepts, on a structured level. And our job at Textkernel is to make technology to help build the bridge, so to say, between these two sides in the market, people and jobs and their written profiles. We are here in Amsterdam. This is a view from our office in Amsterdam North. We have been in business now for 15 years. I'm one of the two founders of the company, and we currently have grown to a little bit over 75 people, mainly in R&D, so natural language processing, semantic search, machine learning type of software engineers who work in our mainly in our headquarters in Amsterdam North on these semantic recruitment technology products. And we have over, I think, 600 direct customers, large staffing agencies, employers, job boards, and other software vendors. It's all interesting and nice, this technology, but really what's the value for professionals in the labor market? Recruiters simply want to fill their jobs faster and with the right people, or better qualified people. So we're contributing with our technology towards that goal. If you're working with CVs and jobs and you have to manually enter all the data, do complex searches, do complex analyses on data, this can be very tedious routine tasks. So our computer understanding of these documents contributes towards making these processes more efficient and saving a lot of time. And if you are able to move from unstructured data towards structured data in a good way, obviously you can, in large volume data sets like all the jobs in the market or all the CVs that a large company has in their database, you can gain a lot of insight and understanding. Our software is often embedded in third-party software from companies like Oracle or Bullhorn or SAP and the like. So we are not a well-known consumer brand. We're kind of behind the scenes building these engines and data sources. Sometimes also serving direct customers such as large staffing companies who build their own systems like Adecco, Randstad, Manpower, job boards like Monster and Stepstone, and large employers. So semantic recruitment technology is kind of all these steps that have to do with processing unstructured data in the whole recruitment and talent acquisition life cycle, and how that exactly fits into a process is always different, but it's kind of always the same components. So we produce CV parsing software and job parsing software to go from unstructured to structured data. Then we make that searchable and matchable for our customers. And we also collect jobs, and that's really the job feed product that I'll be focusing on right now. So as I said, we started in 2003 with JobFeed, actually kind of on the tails of another new development at that time. Of course, the labor market has been monitored forever, I think, with surveys, but in the late 1990s and 2000s, early 2000s, there was a company in the Netherlands who did labor market analysis by clipping out all the advertisements from the newspapers, scanning them, and then having students type in all the coding and all the structured information into a database, which was, of course, a very laborious process. They had, I think, 50 to 100 students doing this every day. And the potential of machine learning-based natural language processing, of course, is to be able to automate it, which is what we did for them. But they still didn't move to the online jobs. They still continued to do clipping, which was very expensive. And we kind of on the base of that development, we started our own service to actually collect the same information, but from online sources in 2003. So what do we do in JobFeed? We collect and categorize all of the millions of jobs from many thousands of sources, job boards, career portals of companies, of staffing companies, of government that we can find. And the result is JobFeed, the largest database of crawled online job ads. And of all these job ads, we have the original text, so the description of the job, and we also have all the structured metadata, like which job category is it, which industry, which location, which company, what are the skills needed, etc. And this we make available as a product, and it's important that it contains both search facilities to search the actual current stock of jobs, but it's also a historical archive. So we have, for the Netherlands, for example, data going back to 2003, which you can also analyze. And of course, this is very interesting for time series or trend analysis. So our aim with JobFeed is to provide a transparent, real-time and historical view of the demand side of the labor market. So what is this used for? Well, our main commercial use cases, customer groups are, I think, most importantly, recruitment and staffing agencies who sell their services to fulfill vacancies or to introduce candidates for vacancies. And obviously, if you know which companies are searching for what, and over time, and you can see the patterns, this is a very effective lead generation tool. So if they can propose a qualified candidate to a company which actually has that need, it's much more likely to succeed than if they just call all the companies starting at A. And they also use it to monitor their existing customers, not only to acquire new business, and monitor their competition. The same type of use is being seen by job boards, because they obviously sell services to publicize, to post jobs. So they also need to know who is currently looking. And they also, job boards also need to do market analysis for more strategic development on the basis of this data. And with the rise of job aggregators, basically it has become quite popular in job boards to actually use all the data in the market as content backfill, which means that basically in a job search engine, you can use the crawled aggregated data to provide more choice for the job seekers. And this is for... So basically, if a job board has data from their own customers, and this produces maybe 10,000 jobs for the job seeker, but there are actually 200,000 jobs in the market, then the job seeker is more likely to go to a destination which has all of that. So for example, also UWV in Netherlands is doing that for providing more jobs to unemployed people, because the likelihood of finding the right job is also proportional to the number. And the same data is also used by labor market analysts in various questions that they have. For example, to analyze on a level of detail which is not available from questionnaire-based data, because it's maybe zoomed in on a very specific region, on a very specific profession type or skill set, and also because the type of data that you mine from online job advertisements, because it's available in full text as well as structured form, and it's analyzable ad hoc, you can ask questions which you would never have thought of when you were designing the questionnaire. So this is Joffe. It's actually a portal which contains all the jobs in a given country that we can find. I will tell you a little bit more about the process, how we analyze all of that. And then you can filter and search on all kinds of criteria like profession codes, industry codes, company size, location, education level, and any type of patterns that you can think of in terms of keywords and phrases. We currently have this data in 7 countries. Here in Netherlands, in Belgium, in Germany, in the UK, in France and Austria, and a little bit in Italy. You will see some numbers later. And currently we are working on capturing all of the US labor market, which is a labor market which is obviously as bigger than all of those other countries combined. So that's quite a data processing challenge. The two basic, let's say, technology components of Joffe are machine learning of natural language processing. So we basically train recognizers or statistical NLP systems to extract the content out of arbitrary input in natural language. So we basically have people, native speakers, label documents in those particular languages, and they mark where is the job title and the location and the company and the skills and the salary and all that. And from that we use learning algorithms to make recognizers that generalize to any arbitrary set of inputs. And this is a nice approach. For one thing, because you don't have to write actually all those rules, which is very tedious. We do write some rules, I'll tell you a little bit about that later. But it's really impossible to write recognition rules for the formats of arbitrary websites out there. If you have thousands or 10,000s or 100,000s of different sources, each with their own layout and formats, it really doesn't scale to write and maintain rules for all of them. And this machine learning approach is much more, let's say, human-like in reading the text, so looking at the words and in the context and making probabilistic decisions about that, and that scales much better and also generalizes much better to new languages and countries. The other technology components, obviously web crawling or web mining. We need to first find in all kinds of proprietary databases and content management systems and applicant tracking systems, those pages which are to be processed. So we use a kind of twofold approach. One, a wide coverage crawler, let's say Google-style crawling, which just fetches all the web pages that it can find in a given country or domain. And on top of that, classification of those pages, whether they're actually jobs or not. And for large sources like job boards or very large employers, we obviously write scripts that directly fetch the data from there. So how does the processing work? I'm not going to tell you all the details. My daughter yesterday, when I was preparing this presentation, said, "You're not going to tell them the secret recipe, are you?" No, just little bits of it. Anyway, so I think this is kind of the classical web crawling pipeline. So you have you're fetching pages with a web spider. So of two types, this wide coverage crawler and specific scripts for some sites. Then you are classifying them into jobs or not. We do the information extraction, so the parsing of those jobs. Once we have the extracted strings, for example, the job title as written in the original document, you can map it to profession codes, you can map company names to company databases, classify the education level and all these kind of things. And once you have that textual data and that meta information extracted, you can do fairly good deduplication because the texts don't have to be identical, but if some level of textual similarity and metadata similarity is looks like a duplicate, you can flag that. And an important part of that process is also the monitoring of the expiration, right? So jobs go offline again. Maybe it's written in a job that you can only react till a certain date, or maybe the job doesn't go offline, but it disappears from search engines, no longer linked. Maybe it's written, this position is already filled, so you have to detect all of those patterns to know what are the currently active jobs. So a little bit more in detail. When we get the HTML pages, so just textual documents full of HTML. So we use statistical classifiers, actually support vector machines for those who are a little bit more technically inclined, trained on large sets of jobs and non-jobs, and based on all kinds of both textual and layout features, these classifiers are then able to make a fairly reliable decision on whether a given web page is a job. Think like 95% accuracy, it's not 100%. Then the parsing. Basically, if you have a job like this, you could write the rules in terms of HTML, like the large font is the job title. This is useful information, but what we do more often is define these rules more as features for the learning algorithm. So because it's not 100% sure, and you have lots of different information coming from different signals in the page. You might also have a job title in the sidebar here. Look at these other jobs, so that's not the job title. So you need to filter that out on the basis of the position and the lexical content, the phrases that you see, and the sequence of things, and the likelihood that you can arrive at a certain interpretation. Obviously, if you have a highly structured kind of template like this, it is very tempting to write a rule, right? So if it says the reference number is right here and you want to extract the reference number, you will want to write a rule. But if you have 10,000 of sources again, that becomes kind of hard. So we use all kinds of machine learning algorithms like Markov models, conditional random fields, neural networks, and also a lot of ontological knowledge. So we know, what are typical job titles or company names or locations. And you can imagine that if you want to go a level deeper in analyzing the textual content, not just the job title and the location and the company, but you actually want to extract out of the job requirements what are all the skills that are needed, or the degrees, or what kind of techniques you will be working with, that this kind of natural language processing approach becomes very important, because you just have arbitrary sentences there, and you need to interpret these words in their context as to whether they are a skill or not. Well, for the deduplication, I already mentioned we use both textual similarity and similarity of the metadata. So if you have strong textual similarity and the job title is the same and the location is the same, but maybe you don't have the company, it could be the same job. But there are all kinds of problems with deduplication, because companies are copying each other's text and posting the same job with a lot of different metadata to distribute it wider. So all in all, it's quite a kind of game of catching up. And now that we have Indeed and all these other job aggregators, job content, and we also supplying the content from Joffe to job boards, you see a kind of large proliferation of duplicates over the web, which we are battling to contain them. How we do the duplication is basically we pass all the new content through this kind of, again, machine learning based classifier, which has these features based on textual similarity and metadata, and decides then, kind of compares every new vacancy with a fairly large, I think, 6-week window of jobs that we have in the system. And if they trigger, then it's a duplicate, and they are added in kind of clusters so that you can see them in the product. So then comes the coding and mapping. We have our own multilingual profession taxonomy, and also for the other fields taxonomies, and for the professions, and I'll show you an example later of why this is nice. Oh, sorry. We also want to align them across languages, because that produces really nice cross-country analysis potential. So we have this profession or occupation taxonomy that contains around 4,000 codes in 3 hierarchical layers. So we have around 24 top-level, high-level categories. I have some sort of bug in my animation. And under that are around 300 job groups, and under that are around 4,000 profession codes, and these are enriched with something close to 50,000 synonyms per language, so that when you find a new job title that's out there in the wild, you can compare them to these synonyms, and we use kind of similarity-based reasoning to assign them to the most likely one. A little bit about the operation of this whole pipeline. It's not too interesting maybe for here, but just to give you an impression. So actually all of these stages and these little processes and these little workers who transform the jobs and classify them and deduplicate them, it's a large circus of around some 150 different steps that have to be done 24/7 to process all of these jobs. So here you see some snapshot of the monitoring system. And I think together with the crawling infrastructure and the processing infrastructure and the infrastructure for the actually hosting the product for customers, it's around some 100 servers that run all of this. To give you a bit of an impression of the amount of data that we process. So these are the 7, now 8 countries that we work on. Of course, it's a little bit different per country, but for let's say for Netherlands, we're actually processing a lot of data because we're doing very wide coverage crawling. So we get basically all company pages and all, well, close to all web pages that are out there and classify them. So for Netherlands, we process around 300 million pages per year. For countries where we are taking a little bit more focused crawling approach, where we really have the entry points for company web pages defined, and we don't collect all of the web. It's on the order of magnitude of, let's say, 80, 90 million pages. Here you see in this column the number of different sources. Yeah. For example, for Germany, we have over 70,000 different sources that we collect. So for Italy, we actually have a very small operation. It's not the real thing. We just collect data from the top 26 job boards. So that's a little bit different.
So the 300 million are the vacancies?
No, are the web pages that are considered as candidates for vacancies. And then here in this column, you see the number of unique job postings that are the result of that. So you see it's a factor of 10 to 100 of reduction in this whole pipeline. And here in the last column, you see the number of duplicates. So you did see that this proliferation of duplicates with around 4 postings per job on average is particularly strong in the Netherlands. And in Germany, it's 1.7.
I thought it was for 2055 to 6 times the duplicates. I've read somewhere. But it's 4. I thought it was 5 or 6 times.
You might be right, but
2015.
yeah, this might be for an older number.
Okay.
Yeah. Okay, so this is just to give you an impression of the amount of data. Now, the interesting question for labor market analysis is it really necessary to put this, big gun machinery to work on this, or are we actually good with just collecting some data? Because if you look at the distribution, the largest platforms, the job boards, will already have a lot of data, right? So if you can get maybe 30% of the whole job market, why don't we do our analysis on that? Because it's technically much easier, and every researcher can crawl their own data and everything. So I compared here 8 weeks of Netherlands data with all the sources that we have active content from in that period, which is around 14,000 different websites for a total of 300,000 jobs, unique postings, with the top 10 job boards, which is around 1/3 of that. And do we get the same distributions of the interesting data? So I looked at one very simple distribution, which is the job categories. So the blue is the distribution for all of the different sources, and the red is actually the distribution for the top 10 sources. And although it's a very large sample, so you would say looks like a pretty good representative sample to me, you see that the distribution is actually completely different. Why? Well, there are all kinds of reasons, of course, but one important one is that if you look at the same data and you look at the proportion of direct employer data versus recruitment and staffing agencies, intermediaries, it's extremely skewed for the top 10. So all the large, the Randstad and Adecco's and Manpower, they have big contracts to post all of their data, so they're completely overrepresented on these large sources. And if you don't go to the company websites, you actually underestimate the distribution of jobs as they're given by direct employers by a factor of, I think, close to 3. So that's important thing to keep in mind. I mentioned already that we have this aligned profession coding for all the countries. And one of the nice things, of course, of that, and you see an example of that here, I think it's also from 2014, we do these kind of profession class cross-country analyses. So you can see that, you know, for example, in France, there's a lot less IT jobs than in Germany and Netherlands, which is interesting. Why? What's going on there? Here you see a similar picture for different sectors. So Germany is the country of industrial manufacturing, right? You can see that very clearly in the actual job data. So yeah, these are all different kinds of questions that you can ask from these data, because you all have it in a database. It's searchable and analyzable. Recruiters can ask these type of questions. Which employers are actually looking for the type of candidates that I have just spoken? Job boards can ask, where are my customers publishing, and which of my competitors are getting also business from my customers? Not all of the jobs contain salary data, but if you have 2 million jobs for the Netherlands and 10% contains salary data, you already have a lot of data points. It might be biased, but it's more than nothing. Or analyze regional employment and profession skills of particular companies. If you look more at the, let's say, less at recruitment, but more at general labor market analysis, you can look at the relative distribution of professions, the growth of professions over time, the correlation of professions with requirements. So, for example, what used to be the requirements for electrical engineers 5 years ago, and how do they compare to now? And also, this is more difficult research question if you're doing all the coding automatically, of course. Are new professions or skills coming up, like data scientists or community managers, or and what kind of skills are asked for those? And just a very simple question, which came from a customer, from a prospect of ours last week. It was a vocational training school, and they're asking a simple question like, should I teach more Linux or more Microsoft technologies to my students to enhance their chances in the labor market? So given the time, I will not, I actually planned to do that question as a demo, but I think I'll show it to you maybe later if you're interested with the tool and we have time. So obviously, with these large amounts of vacancy data, there are also quite a number of open issues. I think most importantly, if we are used to analyzing the labor market with surveys, we know all the methodological problems with that. We know how to correct the data in a statistical way. I think there's very little research done yet on these crawled data sets. How do they, how do you actually use them as reliable information? We have done some work, for example, on weighting factors. So not all information is equally represented online. So you can, correct for that using weighting factors. But especially if you have this crawling process, and it's very, very unreliable in some sense, because a site can change and then your behavior changes. If it's a very large site and before you fix it, it takes a few days, then you have a big swing in your graph. So I think we need statistical methods to correct for these kind of factors. And then another important point I think to consider is that advertisements are not jobs. So the texts that are written to recruit people into a job are a little bit maybe unrealistic with respect to the content of the job, but also a lot of implicit information is left out. If you are looking for, let's say, a neurosurgeon, you're not going to write that they need a medical degree, probably. So, or yeah, there's a lot of skills and educational background that are hidden in the actual kind of implicit knowledge of the job, and that's something that we need to keep in mind when we're publishing on the basis of this data. And one question that's interesting for me, but maybe also for you, is like, do you build your own systems for crawling, or do you actually buy this data from companies like ours? But I can tell you also that for academic research, we are quite happy to make it available for no cost. So few last things on what are the next steps in our type of work. One really interesting area is that there's labor market data online in terms of vacancies, but there's also a lot of labor market data about the supply side of the labor market. There's LinkedIn, there's large aggregators of CVs online, and from these you can actually get the same type of analysis of detail as you can get from jobs. So this is an example from a US-based supply and demand portal, which for a particular job can tell you not only how many jobs there are, but also how many candidates are currently looking for that kind of job. It can also tell you the distribution over time and the distribution in location. So we have started doing something a little bit similar here in Netherlands, in the Eindhoven region. Brainport has commissioned the building of what they call a labor market dashboard, arbeidsmarktdashboard.nl. You can go there and register. And it's a nice example of mixing our kind of job feed vacancy data with publicly available statistics data from CBS, from UWV and other government institutions to produce all kinds of nice economic insights from this data. We have also started to build this into the job feed product, which I can show you later. And another area that we are working on a lot is to get deeper into the text of the job, to really look at skills. So we can extract skills, but it's interesting to not only look at that for one particular job, but to look at it across the whole set of jobs. And when you do profession coding of the jobs and skill extraction, and you have so much data, you can actually derive very nice skill profiles of professions fully automatically from the data. So here you see 3 different ISCO codes for IT professions, and you very clearly see that it's German data. So in German, system analysts must know SAP, and that's the top skill there. And web developers need to know Illustrator, Photoshop, and CSS. So that kind of completes for us the circle with supply and demand, and matching of supply and demand will rely on this type of knowledge derived from online vacancy data, from online candidate profiles, and the ability to match, let's say, open jobs in the market to databases of candidates, which is what we're doing with our match product. Not very clear screenshot, but here we kind of analyze a job that we found online, parse it into a query, and then can automatically apply that query to a database of candidates. So that's all. Thank you. I just want to close with the words online vacancy mining and analysis. I think it's there's a lot of objections maybe to be made about its accuracy as a labor market analysis tool, but I think it's a very exciting area, and it's kind of the least worst thing that we have, and a lot of fun with the data that we can have. So, thank you.